We're going to take a look at inequalities. Inequalities are very similar to equations in the way that we solve them. We just have to be aware of a couple different things. So an equation has a left-hand side, a right-hand side, and an equal sign. Right, so it looks something like this. To solve this, we would subtract 2. We would get our answer, without a doubt, is 3. If I plug this back in, I'll get 2 plus 3 equals 5. That was equations. Now we're going to talk about inequalities. Inequalities, really the only difference, well, there's two major differences between an inequality and an equation is inequalities have less than sign, the less than or equal to sign, the greater than sign, and the greater than or equal to sign. So that's our major difference there. And our less than or equal to, greater than or equal to sign are going to be filled in dots when we go to graph them. Our less than and our greater than sign are going to be open dots when we graph them. If we look at some of these, we're going to solve them just like we would solve an equation. So if I have the inequality z plus 18 is greater than or equal to 30, I'm going to solve this just like I would solve the equation z plus 18 equals 30. Same rules. To undo that 18 and get my variable alone, I'm going to subtract 18. Now what I do on one side, I've got to do on the other side. So we kind of treat it like it's an equal sign. 18 minus 18 is going to give me z plus 0, which I'm just going to write as z. I'm going to bring down my inequality sign. 30 minus 18 is 12. So now, no longer does z have to equal 12. Z just has to be greater than or equal to 12. So the best way to represent this besides the inequality would be to show it on a graph. If I show this on a graph, we'll give a pretty simple graph here. I've got 12, I've got 13, and 1 less would be 11. If I want to graph this here, what I've got to do, this is where the dots come in. I've got a greater than or equal to sign, so I want to fill in my dot at 12. And if z is greater than 12, I want to point it in the direction that is greater than 12. It's that simple. We've got it solved and graphed. If we move on to the next one, 4x is less than or equal to 20. Same thing. If I have 4 times x to get rid of that times 4, I can divide by 4. 4 and 4 will cancel each other. I want to do the same thing on the other side, divide by 4. I'll be left with an x over here. It's going to be less than or equal to 5. And I can graph this the same way I graphed the last one. I've got 5 here, I should have 4, and I should have 6. We've got x is less than or equal to 5. So I'm going to put a dot that is filled in. And if it's less than or equal to 5, it should be going to the left. Continuing on here, I've got x minus 13 is greater than negative 10. To get rid of this minus 13, I'm going to undo it. I'm going to add 13 to both sides. So I will get x is just greater than positive 3, which I can graph in a very similar fashion. If I look at it, I've got x is greater than 3. So this one's only a greater than sign. I want it to be an open circle. If it's greater than, it should be pointing to the right, because everything on that number line to the right is greater than 3. And my last one here. X over 2 is less than 10. To get rid of that x divided by 2, I can simply multiply both sides by 2. If I multiply both sides by 2, my 2's here are going to be canceled out. I'll be left with x over here, and I'll have x is less than the number 20. So I can graph that just like I've graphed the rest of these. I'll have 20, and I'll have 21, and I'll have 19. And when I go to graph it, if x is less than 20, I want an open circle on 20. Less than 20 should be pointing to the left-hand side. So that's pretty simple. Now the one difference that I talked about, the one other thing that we want to look at here, and I'll just draw an example in there, is what happens when we multiply or divide by a negative. So let's say that I have the example negative 5x is greater than 10. If I want to solve for x here, I've got to get rid of this times negative 5. To get rid of this times negative 5, I've got to divide by a negative 5. If I'm going to divide by a negative 5 on one side, I've got to do that on the other side as well. These negative 5s are going to cancel out. I'm going to have x over here. 10 divided by negative 5 gives me a negative 2 over here. The one thing I have to account for is that when I multiply or divide by a negative, I've got to switch this sign. So this one, which is a greater than sign, is going to be changed to a less than sign. That's the one thing that we've got to keep track of. And now graphing it would still be the same. I would have my number line. I've got negative 2 and negative 1, and we'll throw a negative 3 over here. I've got x is less than negative 2. The less than sign will be an open circle, and if it's less than, it should be pointing to the left.